Welcome. This training video is an introduction to the AERH2S model and is intended for existing or new users of the AERH2S modeling tool. In this video, we will cover an overview of the changes and why they were needed, the importance of including mitigation measures into the model. AERH2S is a complex scientific model for calculating emergency response and planning zones using thermodynamics, atmospheric dispersion modeling, mitigation data, fluid dynamics, and toxicology. The original model, ERCB-H2S, was released in 2010, and changes were needed for the model to run on modern computer systems, to operate more easily within corporate computing security environments, and to incorporate changes based on improved science. These changes included updated source thermodynamics, alignment with Section 23.2 of the pipeline rules, which states, the release volume used in calculating the emergency planning zone in the event of a pipeline leak or break is as low as reasonably practicable. Secondary and minor coding corrections for dispersion calculations, and updated meteorology to more recent years and better coverage. The EPZ is a reasonable worst-case hazard distance, which is now based upon a meteorological maximum instead of a meteorological average. These changes may result in smaller or larger EPZ distances. Larger distances will result for gas pipelines when the model is used without the incorporation of appropriate mitigation settings. This is where understanding operations, especially pipelines, and the importance of entering mitigation settings comes into play. Safety measures are realized by specifying the settings which are referred to as mitigation in AERH2S. For example, emergency shutdown valves. Including mitigation is the new approach for calculating emergency planning zones. Historically, users of the ERCB-H2S model had the option to model either a with mitigation scenario or with no mitigation scenario. For simplicity in modeling inputs, most operators selected the no mitigation method for calculating emergency planning zones. ERCB-H2S previously modeled an EPZ, which was calculated using the meteorological average. However, using the meteorological average, the EPZ represented a relative size of the response distance. The meteorological maximum EPZ with no mitigation represents a very rare scenario in overly large EPZ. Including the mitigation settings based upon normal operations will typically decrease the size of the EPZ if the settings are selected to reduce the release volumes as per the pipeline rules. With mitigation is the most likely scenario. In summary, if mitigation settings are not appropriately selected in the updated model, the EPZ distances may be considerably large and is most noticeable in the EPZs for gas pipelines. Modeling EPZs with mitigation will typically reduce the size of an EPZ compared to the EPZ calculated using the old model and is the new approach when using the AERH2S modeling tool. It is also important that operators understand their own worst-case scenarios for rare events when mitigation measures fail. To ensure mitigation does not fail, operators perform regular maintenance and testing of equipment and infrastructure. Thank you for watching. Please refer to the AERH2S user guide found on the AER website and watch for updates and additional user materials. You can also send an email to the address on the screen for more information.